This is the fast track tutorial about rotation axis machining. It will show you how we created the toolpath for the 1-minute video that shows machining of the wooden Venus statue, Venus de Milo. Obviously we need a multi-axis edition of DeskProto as a rotation axis is used. Here we are, and the first thing to quickly check is the machine. Yes, we want to use this small ISO desktop machine, and the next step obviously is to load the geometry. The Venus STL file is on the desktop. Here she is. Here is the Venus head, a nice small statue. Let me check the dimensions. Well, she's way too large for the small desktop machine, so we need to scale down. Okay, let me open the part parameters. First thing is check use rotation axis, which will make a lot of settings automatically. And then the scaling that I mentioned is in the on the transform tab. The height of the statue limiting factor is that I have a small wooden block of only about 70 millimeters long, and I also want a socle below, so I want to scale down the height to 65 millimeters, which is along the y-axis here. Next step is to rotate, because the height of the cutter needs to be aligned with the x-axis for the rotation axis, which is a -90 degree, and I want to center around the center the geometry. So here we are, nicely aligned with x. Correct dimensions, so we can proceed and go to the material block. That needs to be a bit larger on the left side for the socle that I mentioned, so I put it to custom. Here -7 millimeters, and also on the maximum x side some extra room is needed in order to allow the cutter to sink deep enough to machine the complete top, so I add 4 millimeters on that side. Diameter of the block needs to be larger as well. My block has a bit oversized, it's also squarish, so I will increase that to 35 millimeters, so to make sure that my cutter doesn't go too deep in the first layer. Here we are. Okay, we can immediately proceed to the socle, and I can use one of the support blocks as a socle. So custom block, the left tab, which needs to be a cylinder shape block of 7 millimeters. So here from 0 to 7 you can see the difference in drawing, and it needs to be a circle of 60 millimeters diameter, so I go from -30 to 30, and also here from -30 to 30. And here we are. When I press apply, here is the nice socle. So those were the part parameters. Here is the 0 point on the left side, exactly on the rotation axis. Next step are the operation parameters. Well, first operation obviously needs to be a roughing operation, so let me give it a proper name. 6 millimeter bullnose is okay. Strategy needs to be parallel along the a-axis reverse, so the movements go round, and I want to start at a right side, because on the left side the wooden block is attached to the rotary table. Roughing a bit much smaller layers, 5 millimeter layer height, 1 millimeter skin. I want to use a ramping, that's okay. I want to make the area a bit smaller. Custom start at 4 millimeters, then my 6 millimeter cutter will keep a distance of 1 millimeter to the aluminum rotary table right there. Borders are okay. Movement, let me maybe a bit smaller, and always stay low, which will save me time. And the first toolpath must be much slower, because, well, the rotation axis is not that powerful. Okay, obviously, precision, I need to set precision. Distance between the toolpath a bit below the millimeter, and this one may be a bit larger as the step size is measured along the outside of the cylinder. So going deeper it will become smaller, and my feed rate also a bit more careful. Spindle speed cannot be set for this machine. That needs to be set on the machine itself. Okay, calculate toolpath. Here we are, we go down in a number of layers, -5, -10, etc., until the complete statue is machined. Finishing will be done with a smaller cutter, but before I can make this operation I want to show you here a large vertical plane is present. The roughing operation left a skin here, a roughing skin, so when my finishing will start at full depth the cutter will have a problem with this 1mm skin here. So I want to add an extra operation to remove that skin using waterline strategy. So I call it water lines. Here we are, as said, a smaller cutter, 3mm, .6 accuracy, again 20 millimeters per second on this machine feed rate. Strategy can be water lines with a distance between the water lines of 3mm from top to bottom, obviously, in order to remove this skin. No roughing, and I have to limit the area in order to machine only this vertical surface, so from X7 to X9, that's okay. And now I can calculate the toolpath indeed for only this one operation. It takes a bit longer, waterline calculations are more complicated, but here we are nicely 3mm, 6, 9, etc. until the complete skin is removed, and now we can safely add the actual finishing operation. Here, add operation, finish. Here we are, and for finishing I want to again use the 3mm cutter, precision 3 toolpath per millimeter, again the 20mm per second feed rate. Strategy needs to be around A-axis. I want to use the helix, however that is disabled. Now I can quickly show in such cases you can always use the help file. The help file gives practical information on any dialog. You see detailed settings, and for helix it says that on tab page movement you need to select either conventional or climb, which makes sense. The current setting of meander, go from 0 to 360 and back to 0, is not, well, that for that setting a helix is not possible. So conventional, now I can select helix. No roughing. The area needs to be, can be a bit smaller. I want to finish only the statue, not the suckle, so I make that rectangular from 8.5 to 74. Here we are. Well, no further settings are needed. No, we can just proceed, calculate the toolpath for this operation. And here we are. Indeed, one helix, the cutter goes down here, and in one long movement it ends here and goes up again. And the last operation that I want to add is a detailing operation. So let me add one more operation, detailing. Yes, here we are. Because for the small details I want to machine one more time with an even smaller cutter, 1mm diameter for the smallest details, high precision, 10mm per toolpath. Here again feed rate a bit slower, however almost nothing needs to be removed here. Strategy again around A and the helix, so same as just for the previous operation. Yes, area also a bit smaller from 8.5 to 73.5. 5. Here we are, and this calculation obviously will take a bit longer as this is a very detailed setting. And here we are again, a helix. Let me make this one invisible. Go down here, and one very long movement. It goes over the geometry, and you can see details like this, which were not visible using the 3mm cutter, will be clearly visible now with this small cutter. So we're all set. All toolpaths are calculated. Let me make all toolpaths visible. Yes. And now we can go to the final step and write the NC file. Here we are, write NC file to the desktop. I'll call it VNUS, and as you will see here, a few different files are saved because I use 3 different cutters and my small machine doesn't have a tool changer. So roughing operation is a 6mm cutter. This one is waterlines and finishing, as you can see, with the 3mm cutter, and the last one is detailing with a small 1mm cutter. So we can send these all to the machine and the result will be exactly as shown in the 1-minute video that will follow now.